Hello everyone, today we will do the review for the chapter 8. The first question is find the sum of this summation i's from 1 to 4 I square minus 3. You can open it. Substitute I as a 1. So 1 square minus 3. Then add with the next term. Next term will be 2 square minus 3. Add the next term 3 square minus 3 and the last 4 square minus 3. The first term will be negative 2. This will be 1. Here 9 minus 3 6. 16 minus 3 it's 13. So you can see 13 and 16 is 19. 19 plus 1 it's 20. This is 19. 19 and 1 is 20. So it's 20. And this is negative 2. Negative 2 and 20 is positive 18. It's the answer. Next, we have to write in the summation notation 7, 10, 13. So it's like moving 3 adding. What we are doing? We are adding 3 to it. So 7 plus 3 times n. If you put n 0, it will be 7. If you put n 1, it will be 7 plus 3. If you put n 2, it will be 7 plus 6, which is 30. So your n is moving from 0. The last number should be 40. What you substitute here for n, so your total answer will be 40. So if you check for 10, 10 threes are 30, 30 into 7, 30 plus 7 is 37. So 10 is not working. Let's take 11. 37 is very close to 40. So if you take 11, 11 threes are 33. 33 plus 7 is a 40. So your n, last n is 11. You have to start from 0 and with 11. You can try third question yourself. Next, write a rule for the nth term of the sequence. This is a sequence provided. We have to write its nth rule. Nth rule means general formula from which we can calculate any term of the given sequence. After that, we have to use the formula and calculate the 14th term. We learn about the two types of sequence, geometric and arithmetic. Let's check it's arithmetic or geometric. Arithmetic means if the difference between the any two consecutive terms is same. Geometric is when the ratio of any two consecutive terms is same. 14 and 9, it's a 5. 19 minus 14, it's again 5. 24 and 19, it's again 5. So difference is 5. Every time difference is 5. The first term is 9. So geometric, it's an arithmetic sequence. An is equals to the first term plus n minus 1 into d. Substitute a1. First term is 9. N minus 1 as it is. Common difference is 5. We have to calculate for 14. Substitute n as a 14. N is 14. So A14 is 9 plus 14 minus 1 times 5. So 9 plus 13 times 5. 13 fives are 65. 65 and 9, 74. This is the answer. Okay, next. Write a rule for nth term of arithmetic sequence, then graph the first 6 terms. In this previous question, sequence terms were provided. We can easily find the first term and then write it. But here you can see question number 10 and 11, it's not provided the first term. They provide you 14th and here they provide you the two other terms. We will write that. How to write 14? A14 is first term plus n minus 1. N is 14 in this case. 14 minus 1 times D. D is 3. And A14 is given 42. A1 13 times 3. It's 39. A1 and 42. Subtract 39 and you will get 3. So first term is 3. Let's write its general term. The general term of the question number 10 is first term plus n minus 1 times 3. You can open the brackets. 3 plus 3n minus 3. 3 and 3 cancel and you left with only 3n. So nth term is 3n. Then, okay. Next we have to check this sequence is geometric. If it is geometric, we have to give the reason. In the geometric, it will be common multiple. Or you can say find the ratio. It will be same. 14 by 7, it's 2. 28 by 14, it's 2. 56 by 28, it's 2. So ratio is 2 every time. So either you can say the ratio is 2 or you can say you will multiply by 2 every time. So yes, the common ratio is 2. So it is geometric sequence. Next, write a rule for the nth term of geometric sequence. What is the nth rule? We can choose this question number 15. First term is provided 25. What is the common ratio? Check it. Second term over first term. 5 2s are 10, 5 5s are 25. I am getting 2 by 5. Let's check again. 4 by 10. It's 2 by 5. Again check it. 8 by 5 over 4. It's 2 by 5. Common ratio is 2 by 5 every time. First term is 25. So, we will write the nth term is first term common ratio to the power n minus 1. So, an will be first term we have 25. Common ratio is 2 by 5 to the power n minus 1. This is the answer. Next. Question says find sum. 5 minus 2 to the power I minus 2. So you can calculate, one thing is you can directly calculate 5 minus 2. If you put 1, it will be 0. 5 minus 2 power 1. 5 minus 2 power 2. And so on. 5 minus 2 power 9 minus 1, 8. This is the one way you can do. Another is, it is a geometric sequence in which the first term is 5. So the formula for the nth term of a sum, nth sum in a geometric sequence is first term 1 minus common ratio to the power n over 1 minus common ratio. First term is 5. Common ratio is minus 2 to the power n. 1 minus common ratio is minus 2. We have to calculate for 1 to 9. So first 9 terms we need. Substitute n as a 9. 1 minus 2 to the power 9 over 1 minus. It's 3. So you can calculate. This will be the answer here. Then it says find the sum of infinite geometric series if it is. We can find infinite sum only if it exists. And how to check it exists? If geometric sequence has a common ratio in between -1 to 1. If the common ratio is lies between -1 to 1, only then it exists. So let's see what is the common ratio. Second term over first term, I'm getting -1 by 4. Third term over second term, I'm getting -1 by 4. Fourth term over third term, I'm getting 1 by 4, negative. So every time common ratio is -1 by 4, and -1 by 4 is lies between -1 to 1. So yes, we can find its sum. And what is the sum? This is the first term over 1 minus ratio. The first term is -2, common ratio is -1 by 4. Substitute. -2 times 4 and over 5. -8 by 5 is the answer. Next, write the recursive rule of the sequence. Recursive rule means you have to write the given sequence in its previous terms. So you can calculate the next term only if you know the previous terms. Okay, here you can try the question number 27. In this question number 27, we will see this is geometric or arithmetic. 7, then 3. So we subtract 4. 3 and then 4. We add 1. So it's not a geometric. It's not a geometric, not a arithmetic. Another thing. If I subtract 7 and 3, we'll get 4. If I subtract 3 and 4, I will get -1. If I subtract 4 and -1, I will get 5. So what is going on? We have to subtract the previous two terms to find the next term. So if this is the first term, this is the second term, and this is the third term, I will calculate the third term by subtracting a1 and a2. Try to write in a nth term form. A and plus 2 will be a1 for an minus an plus 1. An plus 2 will be an minus an plus 1. So term, then we add the next. Okay. So if you subtract the last two terms, you will get the next term. And here we need two first terms. So first term, a1 is 7, a2 is 3. Okay. Done. This is recursive form. Now we have to write an explicit form. Recursive to explicit. Explicit like a geometric sequence. How we write a geometric sequence? A into r power n minus 1. You can remember like if question asks for arithmetic explicit form. So explicit form is a form which can be used to calculate any number of terms. In the recursive, we can only find the next term, the very next term, not a 10th term directly. In the explicit form, we can find directly 10th term, directly 20th term, 100th term. We have to calculate explicit in this question. Question number 31, see. First term is provided and you can see the next term is a multiple. You have to multiply the previous term with 2 by 5 to get the next term. So it is a geometric sequence in which the first term is 26 and the common ratio is 2 by 5. So explicit form will be first term into common ratio to the power n minus 1. Okay. So here we have revised the chapter 8. I hope you understand. Thanks for watching.